Yeah, good evening, friends. I am Janardhan Reddy, and I have been selected for Emertxe Information Technologies Private Limited Company for internship program. And this is the project which should be submitted for Emertxe Information Technologies. And our project is IoT based home automation. Let us go. Yeah. First of all, the contents of our IoT, our project is introduction of learned concept, and these are the concepts which have been learned in this internship program. C programming, IoT, embedded systems, controller, and software user. Okay, and with the help of these, I have concluded one project, and the in this project include overview, objective, design elements, simulation, program, and conclusion. You don't worry, we can go each and each step, and there is a project demonstration also is there. Okay, next. And C programming. What is C program? It is a general purpose language, even though it is applied and used efficiently in various specific domains. C program is developed for new applications and developing new games, developing new software applications. So it is used so many applications in our daily life. And simple structure of C programming must and should contain the preprocessor directive and start of program and in program termination and file header and comment. These acts as a comment section. So we describe the comment as slash star statement star slash. Okay, and intimate it is the start of program, return 0 on program termination, and it indicates end of the program. Printf hello world, and the output of this code is hello world. Okay, topics learned in C. In this internship, I have learned these topics related to the C program, and which is data type modifier and qualifier, and it describes about at what data type we are used in this program. For example, print 5. Type 5 means it is integer. So like that, the conclusion of data type modifier we are used, and conditionals and loops. So conditionals means as we know later, if else if like that, and loops means while loop, do while, and for loop. These are the sequential manner. And operators, what are the operators we are used here? Relational operators, bitwise operators, etc. We are used. Arrays group of homogeneous elements in a container or anything box. Okay, functions, set of statements to perform an action, and storage classes and preprocessor. These are the topics we have learned. Okay, and internet of things. What is internet of things? Nothing but internet of things, nothing but a collective network of connected devices, and IoT system works through the real-time collection through exchange of data. Normally exchange of data between one object to one object via internet or cloud based, acts like a internet of things. Okay, and in our daily life, we have gone through industrial, consumer, and applications, household applications like that. Okay, internet of things applications. What are the applications? Mobile, manufacturing, logistics and transport, and for business we are using so many applications. Not only this, and examples also smart cars, smart buildings, home automation, wearable health monitors, like that. With the help of IoT, we can reduce the time. We can reduce time management and if increase in efficiency of systems, etc. And embedded system. What is embedded system? A combination of hardware and software designed for a specific task or function. These are very low powering small computers embedded in their mechanical and electrical devices. Generally, they comprise the processor, power supply, memory, and communication parts. So, in the embedded system, we have used these types of systems. First of all, sensor, which sense the activity and it converts physical quantity into signal, and an analog to digital converter and its processor through the cloud or memory, and it again converts the digital to analog converter, and it's at last it acts like the actuator. Actuator means the signal which have get the signal into the, it converts to the physical quantity. Embedded systems and applications we are using in our daily life for electronics, robotics, security systems, telecommunications, automotive, industries, medical field, etc. And examples for embedded systems are implanted heart monitors, electric vehicles, household applications, railway braking systems, etc. Microcontroller. Microcontroller is nothing but it is a processor which has a internally of memory and input output devices, and a microcontroller is a single chip device which has been implemented for very large scale industries. Okay, and in that microcontroller we have ADC block, DAC block, that means analog to digital converter, digital to analog converter, timers, counters, PWM, pulse width modulation, processor, and memory, microprocessor, RAM, ROM, and its types. Okay. And in this project, what are the software used? In this project, that is home automation. Arduino, and we know that Arduino is the heart of IoT system. Okay, Picsimlab lab. It is it is used to demonstrate the project, and the Blynk application to control. And this is for Blynk application. This is for to control the devices through mobile applications. Okay, virtual serial port, it is used to communication purpose, for one device to another device. In hardware section we use it through wires, like jumper wires, softwares, like that. In software it is impossible to communicate with two devices, so through the virtual serial port we it is possible to communicate each other. At later we can describe deeply. Okay, the overview of a project is this project provides an IoT based automation solution using Arduino Uno board in Picsimulator Lab simulator. Blynk IoT mobile application is used to control the devices remotely. And even our home automation, we can control the lights, temperature of the home, and inflow and outflow of water in the water tank. And this is the overview of project and the introduction of home automation. Yeah, and this is the architecture of our project. Arduino Uno is the heart of IoT, and LDR sensor, light dependent resistor sensor. It is used for garden lights, so that daytime the light will be more, so the lights will be automatically off, and the night time the darkness is present, so the light will be automatically glow through the LDR sensor. And temperature sensor to maintain the temperature in the inner room of the home. And blink app is used to application purpose for on the lights and all the inlet outlet of water flow, etc., etc. And heater and cooler is used to cool the system, and cool the system when the temperature rises. Okay, and LEDs is used to, as I already discussed, LDR sensor is used to describe the light. Okay, and serial tank is used for inflow and outlet of water. And CLCD display is used for notification purpose. Okay, what are the things we are going to implement? That is, it will be notified like string. Okay, the water is full, the water is off, or the light will be insufficient, or like that. Okay, I will show video at last. Okay, the object of project is connect the home applications to the pin simulator lab simulator and integrated with Blynk IoT app using Blynk Cloud. So either it will be software or hardware. Must and should the memory should be contained to access that elements for future purpose. Okay, so we are using the Blynk Cloud through the Blynk IoT app. So through the Blynk IoT app, we can use the control lights, temperature of home along with the level of water tank using mobile app. Obtain notification of the status of home on the mobile phone. Yeah, through the mobile phone, we can download the Blynk Cloud app, so that we can control the lights of the room, temperature, and cooler. Okay, why home automation? Why I choose this project? Generally, people always don't stay at home. This brings the problem of home applications not being monitored. Okay, as you will see, daily life, so many members are not there in their houses due to some work. So there losses a lot of energies by electricity, and we don't know the water position of the tank. Okay, so I developed this project so that home automation enables people to control most of the devices remotely, such as volume of water, garden lights, temperature of home, like that. So in this figure, we can notice that through the mobile application, yeah, and this mobile application we have to download in phone, that is a Blynk IoT. Through the Blynk cloud, we can access the system of Arduino through the Picsimlator lab, through, so that it can access the product of home, that is what are the lights turned on, how much percentage of water present in the tank, and what is the temperature of the room, etc. Arduino Uno. This is called Arduino Uno. Arduino is a microcontroller board based on the Atmega 328 way, and it has 14 pins. 6 will be the PWM output, 6 will analog input output pins, and 16 megahertz resonator, USB connection, power jack, and these are the things present in the Arduino. It has been programmed using different IDE, and it is separate for Arduino IDE. Integrated developed environment is used in this project. Arduino IDE supports C and C++ languages. Okay. Picsimlab. Picsimlab is an open source real-time emulator of development boards with integrated MPLABX, etc. It supports some Piximulator microcontrollers, some simulator of microcontrollers. Okay. It has integration with the Arduino IDE for programming the boards, microcontrollers, etc. For software purpose, we are using Piximulator. There is a lot of applications, so we are using one of them. Okay. Blynk IoT app configuration. So it look like this. While it will be downloaded in the mobile. Here, first we have to create template. Through the template, we have to add device. Through the device, we have to select and add data stream, so that we can implement the data of that project. So that memory we can create one icon, and through the Blynk library we can access through the mobile IoT application purpose. Okay. Okay. What is LDR? Light dependent resistor. So I already said, here see the graph. Resistance is inversely proportional to light intensity. As the light intensity increases, the resistance of the light decreases. So that the daytime the light will be the sunlight will be more. So that the light automatically turn off, and at night the light will be low. So that the lights will automatically turn on. Garden light control, so that I already explained LDR sensor and lights. This is the combination of these are garden light control. So during the day the outdoor light is maximum, so the LDR sensor detects the light and garden light is turned off. So I already said this one. And temperature sensor is recorded using LM35 sensor, which reads analog value. The value is converted into binary value, and later actual temperature calculated using the obtained value of the voltage. Okay. In the range of it is plus minus 1 degrees to over the minus 50 degrees to plus 155 degrees range, and it provides an output voltage of 250 millivolts at 250 Celsius. Okay. Temperature control system. So here see the Arduino is access to the Blynk IoT app and CLCD and temperature system. Through the same temperature system, it will access the temperature, and through the IoT application which has implemented in a mobile, so that we can turn on heater, cooler, etc. to display in CLCD. Okay. Water tank inlet and outlet value control. Okay. So this is also same as like temperature sensor. So that water tank, here the volume of water indicates initial value control, outlet value control. Here we control through the mobile IoT app. So we already created and designed the memory for it, and it also displays in CLCD. Okay. Blynk IoT is a mobile interface. So here showing home automation. Here not showing offline. So it is in online. While in our online we can control like this, the cooler switch, heater switch, water inlet, water outlet on that. Here see the water value 2900 out of 3000, and temperature 35.16 degrees. So here it is the notifications as we like CLCD. It will display on CLCD. So tank is full, turning off the inlet value. So like that it is implemented. Don't worry. At last, I will show a demonstrate of project. Okay, simulation image, and these are the simulation image which have to be implemented. So here the water, see the water is inlet to into the tank. So here the inflow, the display in this project is inflow, and volume is 2150 out of 3000, and temperature T means temperature 27.34 degrees, and this is the Pic Simulator Lab. Through this we can access these elements. Okay, yeah, and programming. First of all, LDR sensor. What is the program for LDR sensor? First, we have to it is declare the code for LED pin mode. We can access through pin mode, and 3 and output. So here the output we can get at pin 3. Okay, and input we are giving for LED sensor are A0. A0 is analog input. We are giving input, and output we have taken at pin 3. So that analog input first we have to read, and on that analog input we have to convert to digital, so that the LED will take digital value at pin number 3. For converting analog to digital value, we give a formula for 1023 minus analog value divided by 4. This is the simple program for blinking of LED, and this is the way for LED display. Uh, so for this we have to install some of the libraries called wire.ho, liquid crystal slash I2C.ho, like that. And for that, here see IC LED LCD set cursor 0, comma 0. It indicates 0th row and 0th column. This is for notification purpose, and this is for interfacing. Same like that, we have given where the it is interfacing, where it should be displayed, where it should be converted. And for this is the temperature, so that analog value first we have get the analog value that should be converted into voltage. For converting the analog value into voltage, we have the formula like analog value multiplication of 5 divided by 1024, and that voltage we have to convert the temperature equals to voltage divided by 0.01, so that temperature we should be in string value. So here we convert string, it is displayed in the CLCD LED display, so we have to take the string value only. And here is PWM project moniker, so that we have delay and analog right. So this is analog right, what which pin we have to take, and what is the purpose of that pin we are used. And this is useful to blink LED, and it is also useful to blink IoT cloud application. Okay, and it is a serial tank which is used for inlet, outlet, and volume. That's all. So that we have to install some libraries, liquid crystal, and LCD clear means it clear the previous values, and like that. Okay, yeah, in conclusion, in summary, this project provides a solution of monitoring controlling home application on certain devices remotely using Blynk IoT application of Picsimlator Lab simulator. Home automation project is simulated where LED and temperature system, serial tank, seasonals, light, heater, cooler, and water tank in real time. Blynk IoT applications allows users to control these devices according to your wish, thus accomplishing home automation. So in our project home automation, we can conclude and control the lights in the home and volume of water tank, and if the temperature is increases, we can automatically turn on the cooler, so that okay, so that we can modify according to our purpose. So here I am taking volume of water 3000, and I am using the sensor temperature sensor is LM35, like that. Okay, let us show our project demonstration so that we can clearly understand. Okay, now now onwards we are using theoretically and practically we are using now. Okay. 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 And this is the code what we are discussed here. And this is for a temperature system. And this is our ID. So that so what are the seal and we if we else these are the code. And if the heater will be high, if control will be in our control, then the heater will be high. If controlled, or else digital right heater low. This is the right. First we have to the verify our code. Yeah, it is successfully executed. And sketch export compared library. And this is also a verification only. So, yeah, the both we get the successful code running run. Let us open our Picsilab. Yeah. Okay. This is the interface of Piximulator Lab first of all. And we have to select the board. The board is Arduino, and the microcontroller is Atmega 328P. And that and next we have to load Excel. We have to give the code of this. We have to access that Arduino code into the Piximulator Lab. So in that I have the here it is code file loadx, and in the desktop in my name Jana project I have called yeah, this is the code which will be implemented. And next we have to configure. So I already said through the visual serial port we can communicate it with the outside world. And here giving configure com1. And next models on serial remote tank, and we are giving com2 so that it will be connected. Yeah, see, as you see it is successfully connected. And next models we have spare parts. Okay, well, wait a minute. Yeah, okay. Okay, now wait, I will connect my mobile in the PC. Yeah. Okay. Now let us see this one. And here have water inlet. So when I turn on the, we can see here the water is into the tank. So here displayed, wait, see here display when I turn on, the tank is full. So here display tank is full, turning off the inlet value so that the tank will be full. And okay, now let's see water outlet. So here is now, here see water outlet on. So here see the water is running out of the tank. When on when on water inlet, so both will be active. Here see the turning of the inverter. Okay. Now outlet will be off so that the water inlet is moving into the tank and the volume of increases. Here see 2360 to 3000. See 3000. So after the 3000, the full of water, it will indicate tank is full, turning off the net inlet value. Okay. See, and now the heater switch on. If the heater switch on, that here see the temperature will be increases. As you see here also. Here temperature 33.16. Yeah. See, here both will be showing right. 34.8. See, here temperature is above 35 degrees, turning off the heater. So automatically turn off. So here I give the limit of 35. So when the temperature reaches the 35 degrees, the automatically it turn off the heater and it's turn on cooler switch. When I on the cooler, it will decreases gradually. See 36.35, 0.16, 34, 33, like that. So here showing the correct output. So here 32.72. Here also it is also this is for CLCD display, as we already know. Okay, I turn off the cooler switch. This one, yeah, and this is that situation. So in that I have the home automation. I when I click it, I will access these elements so that water inlet on, water inlet off, on. So here see both will be acts like on. When while the water is in inlet and the same amount of water is outlet, so the volume of container remains same. When I off the water outlet, it will fill the tank. See, okay. Now the water will be automatically turned off because of volume of water is full. Okay, now remove the water of the tank, water outlet on. So here see the volume of is decreases 2710, 2580, 2490, 2430, 2320, 180, 2010, 1920, like that. See, volume of water in the tank is less than 2000 liters, turning on the inlet value. I already say here I give the limit of the tank. When the water decreases automatically 2000 liters, it will automatically turn on the inlet value as we see here like that. Okay. So this is the Blynk IoT app which I access from my mobile. Okay, and this is a LDR sensor. When the light will be low, here the output here see the yellow light is blinking. So when the LDR is low, the light will be turn off. When the LDR is on, the light will be turn on. Okay, and this is for cooler, and this is for LC CLCD notification. So it will describe the notification. Here see, now I turn on the water inlet, so inflow off. Wait, outflow on. See, the outflow is on, so that is it will display on the notification outflow on. When I inflow is on, so inflow is on. So here the inflow is on, and the temperature is 25.342310 as you as I described in mobile application app. Okay, thank you. Okay, if you have any doubts, please put a comment. I will definitely clear your doubts. Okay, thank you, extreme company for my for to help my internship and also and our project also. Thank you.